Hello, everyone. So thank you for joining today's meetup. On our agenda today, my colleagues Walt and Gert will discuss the new flood impact analysis solution. So as a reminder, we are recording this meetup, and we will be posting the recording information to our meetup groups in about the next week or so. So during the meetup, if you would like to ask questions, please feel free to send those along to us. On the bottom of your Zoom screen, you'll see a Q&A option, so please use that as a way to submit questions to us. We will have we'll kind of go through an overview of the solution, we'll go through demos, and then we will have the Q&A. So that'll be kind of following all of the information, so keep that in mind as you submit your questions. So with that said, I'll go ahead and pass it over to Walt and get us started.
Great, thanks a lot, Matt. As Matt mentioned, my name's Walter Potts, and I'm joined by my colleague Gert van Maren, who joins us from New Zealand, where it's early in the morning there. And Gert and I are excited to show you the flood impact analysis solution today. So to give you an idea what to expect during the meetup today, we're going to do an overview of what the flood impact analysis solution is. Gert will give you a demonstration of how it works. We'll discuss some of the data requirements and software requirements. Then we'll take questions, as Matt mentioned. And then finally, we'll end up, and I'll show you where you can go to get started if you want to use it. So with that, we'll get started. To set some context for the meetup, then, we need to understand a few things about why the flood impact analysis is necessary. In this slide, you'll see in the upper left corner there, we have some environmental changes, such as increased frequency of flooding and events that we've seen in the last few years. Also urbanization, which means that there's less drainage areas for the water to flow. On the upper right corner, you'll see some social changes, such as the economic impact to displaced people and roads and bridges and facilities, which increase the recovery cost. But there's also a rising expectation from the public to be warned before the flood, to get rescued during the flood, or help in recovery after the flood. In addition to that, there's technical challenges. At the same time, many communities struggle to find adequate flood data. And without that good flood data, it's hard to understand what the impact is going to be, which can cause what we call an information latency. This latency then can impact the efficiency of the flood response. Many communities are already suffering from recent flooding, and the long-term forecast for stream river flooding here in the United States is really high, as you can see from this long-term stream gauge map. But we also have flooding going on right now in the other parts of the world. And recently, this month actually, the UK has been getting hit hard with some storms and major flooding going on there right now, even as we speak. Indonesia, South America, and Eastern Africa have also been hit this month. So the bottom line here is now is the time to start getting planning for the upcoming floods. We know that the flood's going to come. The question really is, how bad is it going to get? It's just not enough to know the extent of the flooding, where the boundaries are going to be, but we need to know the depth to be able to plan effectively. This series of pictures here from our friends down in Austin help illustrate why flood depth matters. So in this picture on the left here, you can see that at 1 foot, the response can be focused on just those people who need additional assistance, like these pets or pet owners, or maybe some special needs people. So it's relatively unimpactful. But at 3 feet, we need now to get high-profile vehicles to start extracting people from those flood areas. At 6 feet, we need boats and helicopters, so it's much more expensive to extract people from the high water areas, and it's much more risky. At 9 feet flood depth, the first floors are typically inundated in most homes, and people are now either trapped in their attic or on the roof waiting for rescue. So flood depth tells us the degree of impact for each flood stage. If we understand what the impact will be at each flood stage, then we can better prepare our resources. To get ready for the flood, we need some help. We need to be able to help the response planners answer some of these critical questions you can see on the left here, such as like, when is it going to hit? How bad is it going to be? How much staff do we need to have? Where do I pre-stage some of those response crews and some of that equipment? When do we alert the public, and what neighborhoods are going to get impacted, so we know what homes we have to evacuate and what evacuation routes we're going to need to take. If we do evacuate them, where do we take them? How many shelters do we need open? All that information needs to be planned out ahead of time so that we can be prepared for the flood event. So to be able to do that, we need to be able to create what we call a flood response plan. And that response plan should be based on flood depth so we know how to answer some of those questions. This plan here that Brad Anderson from City of Moorhead, Minnesota shared with us has some plans. In this case, it has over 300 steps or actions in this plan for this particular flood scenario. In the center here, you can see this pop-up that shows you one of those actions, and that is to close this gate for an 18-inch storm sewer so that it doesn't back up in the community. And you can see they've labeled these by numbers, and they have several different actions they're going to take, like close off some of these roads, put up some temporary levees to help protect some of these assets, and so on. So this is an example of what might be able to do with a flood plan and get it ahead of time, even maybe train with it. The question is, how then can we identify what needs to be, what's going to get impacted in this flood plan for this particular flood scenario? So to do that, we can use the flood impact analysis. And as it says, it's an ArcGIS Pro configuration that can be used by the mapping technicians to be able to develop flooding scenarios at different stages. You can use it to analyze the impact of those flooding scenarios, share the results with people that need to make those decisions, and then visualize the impact of that flooding, which is very important. This solution was developed in collaboration with several agencies, and I want to thank our development partners for providing us with the requirements and guidance on the solution. If you're on the phone today, we appreciate your help. So how can it help you? So the bottom line is, what can you do with the flood impact analysis solution? Well, you can use it to help develop these scenarios before the flood occurs. Could be weeks or months. And these flood scenarios really are comprised of two things. It's the type of flooding at each flood stage. So different types of flooding include like river flooding that could be caused from a rain event, a severe rain event, or maybe from spring snowmelt, or from a dam burst or something else. Another type of flood event could be from a storm surge or tidal surge, such as a hurricane or whatever, and just sea level rise for those coastal communities. Once you've developed those flood scenarios, then you can analyze the degree of impact it's going to take or have on your buildings, facilities, infrastructure for each one of your flood scenarios. And again, each one of those impacts can be done weeks before the actual flood, so you're ready to pull up that information when you know what the flood is going to be when the flood forecast comes in. Once you've done that, then you can share the results of that flood analysis with your non-GIS users using web maps and apps and story maps and so on. But you can also create compelling 3D visualizations to help communicate the risk of flooding to mitigation planners who then can share it with the public. If someone can see the water, the edge of the water up on the side of their home, they're much more motivated to be able to take action for that mitigation than they would be if they're reading it from a spreadsheet or a chart. So it's very compelling. And then last of all, you can also use it to take a proactive approach to accelerate the whole planning, response, recovery, and mitigation phases for flood planning. So that's an overview of what the solution's all about. Now we need to see it, so I'm going to let Gert show you how it works. Gert, I'm going to stop sharing, and then you can share your screen.
Thanks, Walt. So, as Walt explained, the solution comprises of a ArcGIS Pro project, and that's the project you see here. And within the project, we have several tasks, and those tasks, they guide you through the workflow to analyze the impact of the flood. So the first task is what we call getting to know flood impact analysis. And as we step through the task, it gives you an overview, an introduction of what the solution does, which steps are involved, and it also gives you an overview of the data that is required to run this solution. Now, the input data requirements, I'll talk to this later on as well, but what you need to get started are first and foremost depth rasters. So these are rasters to describe the depth of flooding in your area. You also will need an elevation raster, which is a digital terrain model that describes the topography. And then you will want the feature layers that you would want to analyze. This can be your roads, your bridges, your low water crossings, your buildings, or utilities, etc. Points, lines, and polygons, basically. And then optionally, and I would like to highlight this, If you want to do 3D visualization, that is an optional thing. You don't need to do this, but if you want to do 3D visualization, then we do need what we call water surface elevation rasters, and the solution actually helps you create those rasters. And if we go further, as I said, for 3D flood visualization, you will need these water surface elevation rasters, and I'll show you how to create them in the solution as well. One note here, it's quite important, is that all data must be in the same local projected coordinate system, and the solution will warn you if some of your data is in a different projection. Now, with the solution comes sample data that you can download. You go to this link here, this will take you to the sample data, and that's what I'll be showing you here in the app as well. It just takes you to an item on ArcGIS Online. You download the sample data to your machine, and then we can extract that data. You add it to a folder, and then you add the data from the database to your project. And I already did this. You can see here, I have here my sample data. So this is the data that you can get from us. So if we look at the data that you're going to get, what we have here, first and foremost, are our depth rasters. So you get 3 depth rasters, 5, 4, and 3. And you get 3 water surface elevation rasters. And then you get some layers that describe your buildings, your roads, your low water crossings, and your bridge surfaces. So that is the data that you can get started with the solution. And then you can take this task, and that will tell you to open up our second task, how to use flood impact analysis. The first thing we need to do to get started is to prepare our depth rasters, because these depth rasters might have really funny names, as you can see here. Mine are called, just something that is not very logical to the user. So we have a number of steps that prepare your depth rasters and put them into a new geodatabase with logical, consistent naming. So if we go to the first step, let's prepare our flood depth rasters. There are a number of tasks in there that kind of clean up your data. The first one here is to remove negative values. I've seen some sample data from some of our users that had actually negative values in a depth raster. And if you think about it, you cannot have negative depth values, right? So we need to get rid of those values. And this tool will help you with that. You will input your raster and then say my replacement value for the negative values is no data or another data that you can't use. Then there is another quite useful tool in here. And again, this is purely, these tools are purely there to really clean up your data. Because I've seen, again, depth rasters where the depth values within the area where there is a normal flow of the river, those depth rasters are inaccurate. And this is caused by, typically by when the depth rasters are created, they don't have good information about the channel of the river, right? And that leads then to inaccurate depth values. So this tool helps you to extract only the areas that are flooded, so only the areas that are not normally water from your depth rasters. And then finally here, I actually will run this tool because it's one of the most important tools. Here we are going to create our flood depth geodatabase that we'll use for all the analytics. And we're going to input here a depth raster. You need to input them in the order of severity. So the highest flood level comes in first, and then the next, and then the next. And this is important because rasters don't contain any meta information, right? So you really, as a user, need to know what raster describes the most severe flood level and know the sequence of all your depth rasters. And then here in this tool, you can actually order them correctly. And then we can create a new geodatabase. And we can give it what we call a risk type. And basically this risk type, you can add your own risk types here. And I'll show you that in a minute. But basically this risk type gives me, again, a consistent naming of my rasters. So if I call this depth as a prefix, as a postfix, I'll call it meter. And when I run this tool, it will create me a new geodatabase ordered, or the naming of the rasters are ordered according to severity of the flooding. And I mentioned this risk type. You can add your own risk types because we include what we call a risk type table. And this table is actually read from this tool. So this dialog box reads actually these entries. And you can see here, you could add your own row, give it a name, a risk type, give it an attribute base name. This is how your attributes are going to be called. And these are the values of your depth raster. And again, these will be used to name your rasters and also name your attributes. So if we now look at our result, then we have a test depth geodatabase. And you see that we have now very consistent naming. My most severe flooding scenario is now called depth underscore 5 underscore meter, depth 4 meter, depth 3 meters. So we really are consistently naming our depth rasters here. And we do the same, exactly the same thing for our water surface elevation rasters, with the addition of one extra step. Like I said, we allow you to create your own water surface elevation rasters if you don't have them, but then you still need your depth rasters, right? It's one or the other. You either need depth rasters and a DTM, and that will allow you to create your water surface elevation rasters. So you will input your depth rasters here and your digital elevation model, and that will create you your water surface elevation raster. Same tool here, you want to extract only the flooded areas from your water surface elevation raster because, as I explained before, there might be, the values might be inaccurate in the areas where there is normally water. And same thing here, as I showed you before, we create a geodatabase with consistent naming according to severity of flooding. And that gives us two geodatabases. I have them here as well, as I said before, created them before. I have a depth geodatabase and I have a water surface elevation geodatabase. So now we're ready, right? Now we can start to define the impact of the flooding. The first thing, we have a nice tool that really allows you to quickly generate impact areas for your different flood scenarios. So what I'm doing here, when I run this tool, it's going to create me polygon feature classes for the 3 different flood scenarios. So once that's done, we'll go and have a look at those. Here we go. So now I can straight away add those tools to my, there we go, my impact areas, add those rasters to it. And as you can see now, I'll turn off my sample data. I now have polygon feature classes that describe for each of the areas, for each of the flood scenarios, the areas, right? So that is the first tool. And then my next tool is, and you can see we got 4 tools here that allows us to analyze our assets. So if I wanted to run and say analyze roads, I would go and grab my road feature class, which is my sample data roads. I would grab my depth geodatabase, just drag it in. And then you can see here in the risk type, the same, I would take the same risk type that I defined my flood depth database with. And then you select the feature ID on which the analysis should be run. And in this case, it's on flood name, because we allow you to segment the roads into a user-defined segments, but I still want to analyze it per road basis or road name basis. So in this case, we're going to segment the roads into chunks of 50 meters. And as I run this tool, what we're doing now is we're analyzing for each road segment how deep the flooding is going to be on that particular road segment. So we let that run, but we can already look at our results, and we'll turn the other ones off. So if we look at our results, just in the interest of time, you can see as it comes back, we just get the roads that are impacted by the flooding events. And if we look at the attributes of this feature class, what the tool actually does, it creates these attributes on our feature class. It actually makes a copy of your feature class, so don't worry that we're messing with your original data, but it makes a copy of the feature class and then adds these depth attributes. So you can see here for each flood scenario, so level 5, at level 4, and level 3, I'm calculating for each road segment the depth of flooding. So the solution is done now here. Then you can add the symbology. So I already showed you the results, but within the tool, you just get the option then to symbolize it yourself. So if you go, in this case, I always use graduated colors. I go to one of those attributes that just have been generated. So let's say we wanted to see the roads affected at flood level 5. You give it a nice color ramp, and we have the impact of our roads due to this flood event. Okay, so that is very simple, basically. We're just calculating some attributes on your roads, and these attributes describes the depth of flooding for that particular segment. Next tool is if you have low water crossings, you also want to know how deep they are going to be underwater, because the depth of flooding really matters if you drive through it or not. So same thing here, you input your low water crossings, you grab your depth geodatabase, you set your risk type, your ID, and you can even set it a buffer distance that in case your low water crossings are not exactly at the river crossing, because I've seen low water crossings just on the side, on the bank, you can give it a buffer, so it will take into account a bit of a larger area. So as you run this, same thing's going to happen as what we had with our roads. It will calculate a number of attributes, features, in this case your low water crossings, and will calculate the depth for each flood scenario. So as you can see, these tools take a little bit of time to run. I've ran them on larger data sets as well. So you typically can expect anywhere between a couple of minutes and half an hour or an hour on the number of features that you want to analyze, and also the number of flood scenarios, of course, different flood levels, right? But I ran it on 300,000 buildings, and that took about 18 minutes to run for 4 flood scenarios. So that sort of kind of gives you an indication of the time that is required to run through all these impact analyses. So we did our low water crossings, same thing as the roads. You can give them a nice symbology, and you would decide the field. So you can do any of the flood scenarios, and you colorize them then by depth. Now the next one is a little bit more involved. For this case, we allow you to analyze the impact of the flooding on bridges. And in this case, we don't calculate the depth of flooding, but we calculate the height of the bridge above the flood level. Now, when we're going to do this, you will need to have 3D features for your bridge surfaces. And because most folks don't have their bridge surfaces, excuse me, as 3D features, we've included this extra tool that allows you to extract the bridge surface from your LiDAR data. What you do need, though, for this is that your LiDAR data has your bridge surfaces classified. So if I bring in my LiDAR data, and again, this is in your sample data, you'll get some LiDAR files and you'll get a last data set as well. You bring that in. And in this case, the bridges are in class code 17. And as you run this tool, what it will do, it will go into your LiDAR, look at the points that have class code 17, and will try and create 3D geometries for those surfaces. So I've seen quite a few LiDAR data sets that have the bridges classified. For example, I worked with a data set in Austin, Texas, and for a county, they had good LiDAR there, and I was able to auto-extract 3,000 bridge surfaces in about half an hour. But you really would need to check the properties of your LiDAR data to see if your bridge surfaces have been classified. And if not, there are ways to, within ArcGIS, to classify them manually. But I won't go into that during this webinar. But now we've created our bridges. So if we go have a look, you can see here now that we've created these 3D bridge polygons. I'll show you in a minute that they're actually, they are 3D. And then same as with our roads, the low water crossings, I can analyze my bridge surfaces. So in this case here, because I want to calculate the height above the water surface and not the depth of flooding, I need to bring in my water surface elevation geodatabase, right? So I have one here, you can create it with the sample data as I see it before. And again, same thing, you would enter your risk type here that you've done before. And as you let this run, we can already go to the results in the interest of time. But we'll get our bridges, and the same thing if I look at my attribute table here, you can see that now instead of a depth attribute, I have a height attribute, and this describes the height of the bridge, the minimum height of the bridge surface above the water for each flood stage. Okay, so now once this is finished calculating, we'll go to the last tool in our solution, which will calculate the impact, the depth impact on your building features. And your building features can be building polygons, or they can be actual 3D buildings, what we call multi-patch feature types. So we let this run for a wee while. We're doing this live so you can see it actually works. But I won't run the buildings live just in the interest of time and keep this webinar flowing. So there are my bridges. And then, as I said before, you get these attributes calculated on your bridges. And in this case, you get one extra feature class, which is a point feature class at the midpoint of the bridges, which is very helpful to add some labels on. So same thing here, you can symbolize your bridges. We'll skip this now. And then
hey, Gert, I'm going to interrupt you and ask you a question. I've noticed a lot of times for that point on the bridges that you label it with the height, depending on which scenario, which flood stage you're interested in,
Yep.
to be able to give guidance on how much clearance you're going to have for each of those bridges. So I assume
Yes.
you did that. Cool.
Yeah, exactly. And it especially comes into play when you visualize it in 3D, as I will show in a minute as well. Then you can have the labels really floating above your bridges. And then analyze your buildings. As I said, it can be polygons as input or 3D multi-patches. But I mean, you've already guessed the pattern here, right? What you do is you bring in this, we actually give you 3D buildings that are called buildings underscore LOD2, but you can also use the sample building footprints. Again, same thing, dragging the depth to your database, define your risk type, and set a feature ID on which we're actually going to do the analysis. So I won't run it here just in the interest of time, but the result is same thing. I will get my buildings, and then on the buildings, you will see same thing. We've calculated a number of attributes here that describe the depth of flooding. So you can see here, the degree of flooding on these buildings is a little bit different because they're deeper in the water. So that's the buildings. And then once you've done all this, you can share this information as web layers to be used in other applications, right? So one example is our situational awareness viewer. And I'll let Walt talk to this one.
Yeah, sure. So this is a web app, but those of you that may not be familiar with it, it's called Situational Awareness Viewer. You can get it from the solution side as well. And what we've done here is basically we just shared those layers that Gert did the analysis on. So you can see in blue, there's the impact areas at different flood depths, the buildings, the bridges. I think we did some roads in here as well. So Gert, if you just select on like where that number -1 is, and you notice that has a negative value. So I think that's a bridge. And so that tells you the clearance. And you can see the other ones that are labeled, like there's one that has a 3 and a 10. So it tells you how much clearance you have at this particular flood scenario. In this case, since it has a negative value, then it's going to be underwater. So if this was during the response phase of the flood, you've already done all your analysis, you've shared it, as I said earlier, that you can do, and you're now looking at it during the operation right before the flooding, you can see that that particular location of that bridge is going to be underwater. So we might want to make some decisions. And we can see down at the bottom, there are some flooded roads. There are bridges that are impacted and hospitals. So if we have response crews that need to be able to get to the hospital, they're going to have to route a different way to get around that low water area. So it gives us some information in advance or even during the flood that we can make some decisions on. Helps us respond to it a little bit more effectively. So this is one example of how you can share the results of your analysis into a web map or web app in this case.
Thanks, Walt. So if we then go back to our solution in ArcGIS Pro, we have also the ability, as I mentioned before, to optionally visualize our flood scenarios in 3D. So there's one tool in particular that's very helpful. You just click on it and it will turn your 2D map that you've been working on so far into a 3D scene. So you don't need to do anything. It just takes care of you automatically. And you can see now here that the scene that I've been working on has been turned into a 3D scene. So I have all my buildings in here. I have all the bridges that are created in here. So you can see here now, if you look at these bridges, they are 3D and they sit off the surface, basically extracted them from the LiDAR, right? So if I just turn on my prepared, so these are all the results we just generated, right? But here is the scene that I prepared earlier. You can see I have 3D buildings, and I have my low water crossings. I got my bridge impact points, and I got my roads. Turn all that on, then this is kind of the end result that you're gonna get. One thing about these 3D buildings, a lot of our customers don't have 3D buildings, but we do have another solution that we can point you to that will extract these 3D building forms from your LiDAR data and give you sort of a visualization what you see here now. You get a 3D buildings that are quite simple, but they do describe the roof form, and it really gives you a good start when you want to get started in 3D visualization. So of course, here, when you go from 2D to 3D, that's an automatic step, but you might want to change some of the symbology when you look at it in 3D, that's totally up to you. And the last thing you would want to do is add your elevation surface to the surface in ArcGIS Pro, because when you turn it into 3D, we turn on our world elevation surface, and that surface might be not as accurate as your own elevation data. So in that, you should bring in your own elevation data to enhance the elevation surface in the scene. It comes with the sample data as well. So if you get that DTM extend 1, if you add that, then it gets meshed up with our world elevation surface, and you get some better definition of your terrain in 3D. So now we finished. We turned our 2D map into 3D, but the only thing missing, and what really helps when showing this flood impact in 3D, is to show the water levels in 3D. And we have a tool for that. It's called Create 3D Flood Levels from Raster. And it'll be very recognizable because it has the same setup as all the other tools. The only thing now, in this case, you would bring in your water surface elevation rasters that you can create using the solution. So we'll bring in the water surface elevation raster. You can give it what we call a smoothing factor that smooths out the water surface. Tidal surfaces are if your data is in a tidal projection, which in this case it's not. And then you run this tool, and then the result of that will be that go to this one, which I already prepared earlier. You will get to see your water surface elevation in 3D. So this layer here that you see here now was generated by this tool. In the interest of time, I'm not going to run it. But what you can see here is that we actually see the water go up to the side of the building. And that really enhances, especially when you show this to non-technical people, what the actual impact is going to be. And what Walt mentioned earlier, these points now come into play very nicely in 3D because I can use those points for the bridges to really label them above the bridge. And that shows me that this bridge is going to be nearly 6.5 meters above the water level for this particular flood scenario. Now, as I mentioned before, you don't have any 3D data, especially no 3D buildings. We have another solution. It's called the Local Government 3D Base Map solution that allows you to generate the buildings. There is a link in the solution that will take you to that download. You can generate these buildings yourself. The Living Atlas might have some information, or third-party businesses that have 3D buildings that you can use. All the other information can be 2D, and you can run the analysis as necessary. And finally, also this 3D scene I can share to what we call a web scene. Web scene is the equivalent of a web map, but then in 3D. So if we look at one of our web scenes. So this is the one that was published using our sample data. So if we go and zoom down a bit, you can actually see that now in 3D, you really get a really good impression of the depth of flooding, the impact of flooding. You can see here at the end of the street, these buildings are going to be significantly underwater. So my response here will have to be different. And the same for the bridges. You can see here, the labeling comes across as well. And you can see this bridge is only 1 meter above the water. So I might, if my flooding hits this scenario, I might want to keep an eye out this bridge.
Gert, I'm going to add one more point in here. You notice that he's going through this web scene, that the roads, the bridges, and buildings, they all have this same color gradient we've used. So we typically have used some like yellow to orange to red to show the degree of impact and make it kind of consistent. Just makes it a little bit easier for you to communicate that information to non-GIS users.
Yeah, exactly. And just to show you that, you know, it works at scale well. So in this case, we have, like I mentioned before, this is Austin, Texas. It's about 300,000 buildings. All these buildings have been generated. These 3D buildings have been generated using the local government 3D solution. So this is sort of the kind of 3D quality that you can expect to get using that solution. But it's about a million trees, 300,000 buildings, and then you can analyze the flooding. In this case, this is Hurricane Harvey, where we showed the impact of flooding. And the same thing here, right? The buildings are colored according to depth. So the darker the red color, the deeper the flooding is going to be at that particular location. And the same goes for the bridge heights. So in this case, you see here, this bridge is going to be underwater. It's a -1, so we might want to keep an eye on that one. Now, as I said, this web map is very similar, web scene is very similar to a web map, and I can embed it into other applications as well. So one thing we are experimenting with is embedding this web scene, this flood impact web scene, into a dashboard. So in this case, we have here Wellington, and this is sea level rise. So this is not riverine flooding. It works just the same for sea level rise. But if I say here, I want to go and show the impact of 3-meter sea level rise, I can see it visually, but in the dashboard, I also get then the numbers back, you know, the impact of that 3-meter. So you can see about 6,000 buildings are affected at this level, and there is a whole bunch of road at different levels of impact that you get the numbers for. And same thing, if you want to then show a different scenario, 5-meter sea level rise, of course, more buildings are affected, more roads are affected. So this is something, once you've had your web map or your web scene, just keep in mind that you can leverage that product, that end product, into a whole range of different applications. And I'll hand it back to you, Walt.
Sounds good. Why don't you stop sharing, and then I'll share my screen, and we'll get to some of the data requirements then. Okay. One of the things we hear quite a bit about is depth values and data. So Gert, I'm just going to ask you to kind of help explain a little bit so we can get an understanding of what we mean by flood depth.
Okay, and this is just for folks that are kind of a bit confused about, you know, all the different terminology that we use. But as I said, we have basically 3 different kinds of rasters. And the first raster that we have, as you see in is the ground surface. And that describes the actual topography of the surface, and we call it DTM, sometimes called DEM. That's one of the rasters you're going to need. And then the other raster that's really important is the depth raster, and that one describes the depth of flooding for the areas that are going to get flooded, right? And that's what the red arrows indicate. So I really need to know for the area where there is going to be water, how deep it's going to be, for each raster cell. And then the third raster is what we call a water surface elevation. You can generate that in the solution, and that describes the actual elevation of the water surface. Next slide, Paul. So this is kind of, you know, in a picture way what a raster looks like, and these values, all these little blocks represent one cell of the raster, and every raster has a value, and that describes the depth. And in this case, you don't see any negative values because depth can't be negative. So the no data values just describe where we don't have any depth information. Next slide. So where are you going to get that data? So to use this solution, you need to have flood depth rasters. The solution does not create these rasters. You already need to have them. And where can you get them? Well, you can get them from engineering firms. There's a lot of consultancies, engineering firms that generate these rasters. You can also look at FEMA. The solution points you to a FEMA site where you can download these depth rasters. The Army Corps of Engineers also has software that allows you to create these depth rasters. And you could also talk to your account representative and see if Esri Professional Services can help you out generating these depth rasters. A DTM, most of the organizations do have already a DTM available, digital terrain model, the ground surface, or you have LiDAR, and you can generate the DTM of that. Then the assets that you do want to analyze, they need to be points, lines, or polygons. It's very simple, and most organizations have this. So if you have points, lines, or polygons, you can analyze the depth, the impact of flooding on your assets. As I said, water surface elevation is also raster. This is optional. You can get it from the same sources where you can get the flood depth rasters from, or you can generate it using the solution. And in the 3D buildings, as mentioned before, we have what we call the local government 3D base map solution that does allow you to create these buildings from LiDAR, or you can also look at your own GS department or third-party businesses that might be able to provide these buildings.
Cool. Thanks a lot for going through all that, Gert. Also want to talk a little bit about software requirements. As you can see, we have on the list here that you will need ArcGIS Pro 2.4, 2.5 in the advanced edition. You'll need the spatial analyst extension and the 3D analyst. And then for hosting, as Gert was showing you there, you can share your results, either ArcGIS Online or ArcGIS Enterprise. Anything else I need to add to that, Gert?
No, that's it.
Okay, cool. All right, why don't we take some questions now? You guys have been very patient waiting for us. So Matt, do we have some questions that we can answer?
Yeah, so in terms of the analysis, there's a question about does the analysis is it only calculated in meters like we were showing, or can you use US feet as well?
Go ahead, Gert.
No, it uses the units of the input data. So if the raster depth rasters describe feet, it's feet. And if the depth rasters describe meters, it's meters.
Okay, and then I guess kind of question leading from that would be how many levels of depth areas can be created. So in this case, is it same kind of curious about the foot, so a depth at every foot or every meter?
Well, again, if your depth rasters describe your different flood scenarios. So if you have depth rasters that describe flooding at every foot, it will work. So it's totally dependent on the input data.
Okay, and then another question, could a negative value for a depth raster give an indication of high water tables in a flooding event? So, which may be valuable to assess basement or underground parking flooding events?
I would have to think about that one a bit more. In my case, in the cases I've seen, there always were data errors. So I would have to see actually the data where positive, negative values in a depth raster would actually mean something. And, so no conclusive answer there.
Okay. And then a question was, how is a depth raster created for a stream?
Well, as I said before, so there's this software that you can use to create these depth rasters for a stream. Internally, we use what we call ArcHydro, but there is also HECRAS, and there's lots of different software out there. And Walt might know some other software as well that allows you to create the depth rasters for streams.
Yeah, there's a lot involved in that. Typically, a hydrological engineering firm is going to take a look at the elevation data. Sometimes they'll go on site, they'll do cross sections of a stream, and to figure out what could be the depth at each one of those elevations, the cross sections at each one of those elevations. We've seen some cases where that could be, if it's a large area, multiple counties, like on a long river, it could be in the millions of dollars for them to do an engineering study, or it could be a much smaller amount if you're just doing a smaller reach of a stream. But yeah, like you said, HECRAS is one way to do it. ArcHydro's, there's the team that can help you develop that or create that data for you, and the professional services if you wish. So there's a lot of different options for you to create that flood depth data.
All right, and then so another kind of in the analysis realm of questions, what accuracy can you get for a water depth up the side of a building? So registering the image with absolute height, the user is working on a visualization solution that wants to achieve plus or minus 4 centimeter accuracy.
Well, if all the data is in the same projection, and especially the vertical coordinate system needs to be the same, so it needs to be known and needs to be the same, then the water level will sit at exactly the value that is described in the water surface elevation raster. So whether that value that sits in the water surface elevation raster is accurate up to 4 centimeters, that is a data quality issue. But the visualization will sit exactly at the level that is described in the water surface elevation raster.
And then a kind of a series of questions more of talking about when you mentioned the data sources. So has anyone used the EBFE data from FEMA in this process that we were discussing today?
EBFE, I'm not familiar with that one.
I'm not familiar with that one either, but the input that we require is a raster or a TIFF. So if that data is in that format or can be converted into an Esri raster or a TIFF, then you're good to go.
Okay, and then would it be possible to link flood values to tidal or river gauge values from the NOAA services?
Yeah, that's a good question. I think the best way to do that, and I've thought about that quite a bit, is to do the analysis ahead of time so you know what the flood depth is going to be. So you have these scenarios, potential at least, done ahead of time, so you know what it's going to be at a given point. Then you can use, there's in the Living Atlas, there's the water data model, and it'll give you a 10-day flood forecast, and I think it gives you an hourly flood forecast for up to 36 hours, if I'm not mistaken. So you can lay that layer in there, and that'll tell you what the values are going to be at a given point. I suppose you could use a point for those stream gauges, and say, okay, when the flood water gets to, if we expect it within the next few days, the flood is going to get to stage 5. Usually those stream gauges, they'll tell you what it's going to be in a stage or something like that. Then you could pull up the analysis you've done for that stage, that flood scenario, stage 5, and then it'll help you plan ahead what's going to get impacted. So what I would do, probably to answer that completely, I would probably take that situation awareness map that Gert was showing earlier that has those flood scenarios in it. I would have them at flood level 5, 6, whatever. And then I would lay in the Living Atlas that shows us the data from the Living Atlas for the flood forecast. And then I would be able to see which layer I need to pull up and turn on right before the flood occurs.
And then one more one more kind of depth raster analysis question. Would you rely on a raster generated from effectively, or could you rely on a raster effectively subtracting the ground surface from the water surface if there's not data available from FEMA or engineering firms? I guess it's a question of if you didn't have that. Yeah.
A simple answer, yes.
Yeah.
Well, basically in that slide that we showed that had the 3 rasters, that is basically how they relate to each other, right? So if you subtract the DTM from the water surface elevation raster, you get a depth raster. So that's yeah. If the data is not available, that's your next best option.
Excellent. And then someone's asking on kind of a expected costs for a consultant to provide services to a small community, say 5,000.
Yeah, that would be. Yeah, it's certainly not based on the population. It's really going to be based on the amount of effort they need to, how much of the river they're going to do the analysis on. So I really couldn't answer that.
Okay. And then is this supported for other languages such as French?
Yeah, it just uses ArcGIS Pro. So, you know, the task, I'm not sure how they would transfer over into another language, Gert. I don't know if you have an experience with that.
No, that's a good point. I'm not sure if that automatically gets translated over. We can chase that up.
Okay. And then following up to the question about the EBFE data from FEMA, a user was sending more information there, so they in the question form, so we can follow up with them about that. Yeah. So that's all the questions we had.
All right, great. Well, before I let you go, I just wanted to let you know where you can go to get started. There's a couple places, and I just want to make sure that people know. I'm just going to swip over here to the solution site, and all you need to do is just go into your web browser and type in solutions@arcgis.com. When you get to that point, just type in the search, just search for flood. That's a good place to start. It's pretty quick, pretty easy. You'll get a list of solutions from the solution site that including flood, and then right on the top of the list is the flood impact analysis. When you get to that, you'll see the home tab, gives you a little overview of what the solution is, as you've already seen. The requirements that we talked about tells you what you get. In this case, it's an ArcGIS project that Gert just went through, and anytime we add any changes to it, it'll be listed here. Also tells you how you can get started, how to deploy it, how to review the project that you've downloaded. And we have a workflows tab in here as well that kind of gives you an idea about some of those workflows that Gert was walking through earlier. Tells you where you can go to get the data and how to prepare the data and define it and so on. So you can use this information. One thing I do want to show you and leave you with is that if you go back to the home tab, you just scroll down a little bit, you'll see these blocks over here on the right side. This one has additional information, and it has what we call the Getting to Know Flood Impact Solution. Basically, this is a story map that just walks the users through the information that we just shared with you guys. And so you can use this and share that link for this particular story map with non-GIS users to give them an idea of the things that they can do with flood impact analysis. So it's a good place for you to get started. So that's kind of a wrap up, I think, of all the information that we have. Matt, I guess, wrap this up.
All right. So I'm going to go ahead and post this in the chat right now. So we have a survey that we submit for all of our meetups. So you can use the short link. I've also posted the short link into the chat. So essentially, we capture our feedback on every meetup. We want to get better. Maybe there's ideas you have. So please use this short link you have here, and we'd love to hear from you. We also, as I mentioned, record all of our meetups and post them they end up on YouTube, and we link to them on our meetup sites. And so I'm linking to the video recordings where you can find these posted. We usually post about a week or so from the meetup date. So with that being said, we thank you for attending this month's meetup. Our next meetup is scheduled for March 26th, where we'll be discussing the Adopt an Asset solutions. And so until then, have a great afternoon, everyone, and thanks for attending.
Thank you, everybody.
Thank you.